Hello everyone, my name is Piyush Patel and alongside Ashim Shrestha, we're gonna be discussing about issues in packet network interconnection. This paper is one of the oldest research paper and has contributed a lot in the development of the network, which we are witnessing as of now. This paper is legacy of the one of the fathers of internet, Vint Cerf and Peter Kirstein. Paper is published in 1976 and discusses the issue and research work going at that time. This paper outlines how most of the network uses packet switching technology at that time and interconnection of packet switch data networks, along with issues with packet network interconnection and ongoing research with some unresolved research questions. I will be handing over to Asim for the further topics.
I'm going to kick this off with an introduction. Most of the networks uses packet switch technology to transfer information from one network to another and to access any source material in any network. It is a common user requirement that it should be able to access any computing resources that the user may desire, even if the resources is in on another data network. So from user's viewpoint, the requirement for interconnection of data network is independent of network technology. But from implementation viewpoint, there can be some considerable complications in connecting networks of widely different technologies. So in this presentation or case study, we are going to discuss the interconnection of packet switch network and how can networks be interconnected so that packets can flow in a controllable way from one network to another. So these are the terms that are used in the paper, and here is the basic definition of these terms. Hosts are the collection of hardware and software which utilizes the basic packet switching services. Datagram is a finite length packet of data together which has destination host address information, and typically its maximum length lies between 1000 and 8000 bits. Gateway is a network mode that connects two networks and allows data to flow from one network to another. Packets are the block of data transmitted over a network, which are divided into a control header part and a data part. The header part contains information for packet to be routed to its destination. Protocol are the set of communication conventions, including formats and procedures, which allows two or more points to communicate. Virtual circuit are the logical channel between source and destination packet switch. And PTT stands for Post, Telegraph, and Telephone Authority. And this authority has its own meaning or form in different country. Now we are going to talk about motivation for network interconnection. We know that there is a strong interest between both users and suppliers to access the data or packets in different networks, and it's really difficult to carry and manage this type of interconnection. However, the technical interests of different parties are not identical. End users would like to be able to access any resources from a single terminal with a single access port as economically as possible as the user desires. And the operators of the private network often have a vital interest in connecting their networks to other private networks and to public ones. And in this part, we are going to talk about range of end user services requirements and choices for providing multi-network services. The ultimate choice of network interconnection strategy will be strongly affected by the types of user services which must be supported, and it is useful to consider the range of existing and foreseeable user services. And the type of services or general requirements for interconnected services are terminal access to time shared host computers, remote job service entry or RJE, bulk data transfer, and last but not the least, transaction processing. Time sharing and transaction services typically demand short network and host response time, but modest bandwidth. The RJ in file transfer services more often require high amount of data transfer, but can tolerate a longer delay. So these are the end user services which are required across one or more network, but we don't know which services should be provided in data network is it depends on network technology and applications requirement. So in the figure we can see concatenated network connection where A, B and C are data networks connected by gateways, where network A and network C supports broadcast or real-time features but not the network B. So it's really difficult to transfer data packets from host to end users. And the problem of achieving a useful set of inter-network services might be approached in several ways as follows. Either all the networks should support a range of desired services, or all the networks should implement only the most basic services required to transfer data, or the end user should identify the services he desires and should provide some messages if the network or gateways cannot provide the services. So in this way we can have smooth interconnection of data between different networks. Now we are going to talk about layer protocol concepts. Network layering is used to provide services in single network and also to compare capabilities of different network. So in protocol layering, various services are built on top of each other, where each uses the facilities of layer below and supporting the facilities of layer above. And here in the picture, it offers a very generic view of typical protocol hierarchy in a store and forward network, including link control, intranet node to node, intranet end to end, network access, end to end subscriber, utility and application layer. And the hierarchical ordering of function is not always same in all networks. For example, Ethernet versus ARPANET. As you can clearly see the difference in networking layer of Ethernet and ARPANET. In Ethernet, we don't have intranet node to node and end to end layer, while we have it on ARPANET. And in Ethernet, basic link control mechanism is the ability of interface devices to detect conflict on shared coaxial cable. So for example, if transmitting interfaces detects that another interface is also transmitting, it immediately aborts. While in ARPANET, the basic link control between packet switches treats the physical link as 8 independent virtual links. This increases the effective throughput but does not necessarily preserve the order in which packets were originally introduced into the network.
Thanks, Ashim. One of the important aspects of the research paper is issues with packet network interconnection, and thus it was titled by the authors. Authors enumerated various of factors affecting the packet network interconnection and classified those into 6 parts. First is level of interconnection, secondly, naming, addressing, and routing, then flow and congestion control, accounting, access control, and lastly, internet services. We would see it in deeply in the next slide. Affecting levels of interconnection and gateway. Firstly, author describes the fundamental role of gateway, which is to terminate the internet protocols of each network to which it is attached, while at the same time providing a common ground across which data from one network can pass into another. From the image provided below, we can see easily that how gateway connects with various of packet switches and allows them to transfer data from one host to the another. We can see the large networks can be interconnected using this gateway. Authors propose 4 methods of technologies which is affecting it. First, common subnet technology, which can be described as a network interconnection technology strategy that requires the internal address structure of all the interconnected networks to be common. If, for example, addresses were composed of a network identifier concatenated with a packet switch identifier and a host identifier, then addressing of objects in each of the networks would be straightforward and routing could be performed on a regional bias with the network identifiers acting as the regional identifiers if desired. The issue with this technology is such network interconnection method is limited to those cases where to be connected are virtually identical. Second, common network access interfaces. If the subnetwork protocols are not identical, The next opportunity to establish interconnectivity commonly is at common network interfaces. Major issue with this was duplicate packet creation and transmission. So some of the switches might filter the duplicate packets in the periphery, but due to high network traffic, issues was still persisted. Third one is general host gateway. A gateway is indistinguishable from any other network host and will implement whatever host or network interface required. One of the basic advantages of this technology is that almost any sort of network compatible, but the issue with it is every subscriber must implement the internet datagram concept. That is same problem also with the standard network interface. Fourth one is protocol translational gateway. The basic packet carrying service of one network is being translated to the next network's packet carrying service. This is called Common Protocol Transitional Gateway. Now, the issue with it is extending such transitional translation through several can be difficult, particularly if the protocols being translated do not have a common address spaces for network internetwork sources destinations. So we have seen that those are the issues with the levels of interconnections. Naming addresses and routes is considered as one of the most important issues by the authors in this paper. The basic task of packet switching network is to transport data from a source host to one or more destination hosts. So one major question exists is which objects in the network should have names, addresses. Each network needs to know which destination packets are to be delivered. At the lowest protocol levels, it is typical to associate destinations with addresses. But at the higher levels of protocol, it is more common to find text strings as names of destination, for example, multics or BBN 10x. A related issue with this is whether objects should or can have multiple names, address, or routes. The major issue described by the authors is flow and congestion control. Flow control is procedure through which a pair of communicators regulate traffic flowing from source to destination, in which each direction is being dealt in separate method to control flow of data packets. Congestion control is a procedure whereby distributed network resources such as channel bandwidth, buffer capacity, CPU capacity, and the like are protected from oversubscription by all sources of network traffic. Problem with control of flow and congestion is complex, which is not seen generally much in single network, but it is visible when there is a transfer of packets between two different networks. The problem is likely to be visible at gateways joining high-speed local networks to long-haul public network. From the image provided, we can see that multiple networks are interconnected in common internet interfaces. Now, issue occurs when cross-network data transfer takes place at similar time, making it hard for gateway to control the flow of information. So some generic procedure must be needed for gateway to network and gateway to gateway flow and congestion control. Another issue with packet network interconnection was accounting and access control. The major issue found by author was revenue sharing mechanism in public network. Also, subscriber which uses public network needs simple method to verify and review their network usage accountings. Now, during subscriber usage, public networks used to account for their usage based on number of virtual circuits created and the number of packets sent on virtual circuits during accounting period. So, the problem with the accounting is that which method is to choose whether a virtual circuit based accounting or either datagram case accounting. Another aspect suggested was access control, which helps network to establish or enforce policies for out-of-network routing and traffics in multiple networks. Gateways are used as access controller between two networks, which dynamically enable the flow by creating table entries. Problem with the access control is Agreements are bilateral, and for transit routing, it has to be considered as a special case. So these are all the six problems with the packet network interconnection. So to resolve the problems with network interconnections, the author provided light on the CCIT strategy for interconnections and the internet services. Author states that there hasn't been any clear means by which they could separate some of the internet services or could standardize it. The CCITT, which is known as the International Telecommunication Union, recommended virtual circuit service and terminal access service on all public packet switching network. Also, its models of packet networking suggest that all networks should offer the same interface to packet mode subscriber called as X25. X.25 is the virtual circuit interface protocol introduced, while X.75 is interface protocol which is introduced for connecting two gateways between networks. From the image, we can see that X25 accommodates special network to network information exchange. Also, it helps in usage and termination of the virtual circuits between subscribers of the network. Also, the major difference between X25 and X75 is maintaining X25 deals with maintaining sequence of packets, while X75 deals with clearing packets to the next gateway or destination. Now we will look after ongoing research projects and the regulatory issues with the packet network interconnection. There are very well known ongoing research projects like ARPA sponsored internet project and other listed here. The regulatory issues in the interconnection of packet networks was one of the major concerns authors stressed, and especially when it comes to the North America. In all other countries, the long distance communication is provided by a regulatory carrier known as PTT or Post Telegraph and Telephone Agency. There are two service problems that will arise in international connections. First, the impact and form of the privacy and translational data flow regulations in different countries are different. Secondly, some of the functions of networks or gateways legal in one country may be illegal in another. The regulation considers who owns the host and terminals, who owns the switches, who runs the transmission lines, what types of traffic is carried, what is the geographic extent of the network, and what is the technology of the long distance transmission. Now we will look after the unresolved research questions. Author was very kind in providing unresolved questions of that time. Few of the important ones are listed below on the slides. These all important unresolved questions led to a substantial research of TCP/IP protocol by Vint Cerf along with another father of Internet, Bob Kahn. From the paper, we can conclude that the connections between networks can be made at the level of the packet switches or of hosts and can be on a datagram or virtual call basis. Also, the principal problems in connecting networks are much the same as those in the design of the individual networks of heterogeneous system, but the lack of a single controlling authority can make the multi-net design problem more and more difficult to solve. It is essential to resolve the usual problems of flow control, congestion control, routing, addressing fault recovery, flexibility, and protocol standards, along with the economy. Here are the references which we have cited in the slides. Thank you so much for listening to us, and we are open to any questions.